Hi everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology. In this session, we are going to discuss about binomial distribution. Also, derive the MGF of binomial distribution. Using that, I am going to find the mean and the variance of binomial distribution. First of all, binomial distribution mass function is defined as p of x is equal to ncx p power x q to the power of n minus x. Here, n denotes the number of trial and p denotes the probability of success. Q denotes the probability of failure. Here, our x denotes the number of success here. Now, I am going to derive the MGF of binomial distribution. So, MGF formula is it is denoted by mx of t, which is equal to expectation of e to the power of dx. So, which value is equal to, for discrete case, MGF formula is summation of e to the power of dx into corresponding p of x here. So, our p of x value is ncx p power x q to the power of n minus x. So, which value p of x value is substituted here, we will get which value will become summation x value start from 0 to n e to the power of dx. Instead of p of x, I am going to write ncx p to the power of x q to the power of n minus x. Okay, after that, here in this power we are having x, here also we are having x, combined it together we get summation of x is equal to 0 to n ncx p into e power t the whole power x into q to the power of n minus x. Already we know the formula, summation of ncx p power x q to the power of n minus x is nothing but q plus p whole power n. So using this construct, instead of p, here we are having p into e power t. So instead of q here also we have q here. So using this concept, this summation will become q plus p into e power t the whole power n. Okay, this is our required MS of t. Now I am going to find the mean and variance of this binomial distribution. To find mean and variance, to find mean and variance, first of all we should find the derivatives of mx of t. So next we are going to find the mx dash of t. Differentiating this function with respect to t, we get, already we know the formula d by dx of x power n is nothing but n x to the power of n minus 1. Using this concept, q plus p e power t the whole power n will become, using this power formula, so it will become n into q plus p e to the power of t the whole power n minus 1. After that, again differentiating this inner function q, differentiating q with respect to t, it will become 0. And p e power t differentiating with respect to p, we get p into e power t. Because d by dx of e power ax is nothing but a into e power ax. Using this formula, e power t will become, differentiating with respect to t, it will become e power t only. So after that, I am going to find ms double dash of t. So again differentiating this function with respect to t, here I am going to use the UV rule. That means keeping u as fixed and then differentiating v, then plus v as fixed and then differentiating u. So differentiating, first u is fixed, n into q plus e power t the whole power n minus 1, and in differentiating v we get p into e power t only. After that, differentiating this q plus e power p e power t the whole power n minus 1, it will become, using this power formula, n into n minus 1 into q plus p e power t the whole power n minus 2. Okay, then again differentiating this single function, p q plus p e power t will become, differentiating q we get 0, P E party will become P into E party. Already we are having one more P into E party, so it will become P into E party the whole square. So after that, keep this as equation 1 and this one as 2. Now I am going to find the mean and the variance. For finding mean formula is different mx dash of t at t is equal to 0. Putting t equal to 0 in equation 1, it will become n into q plus e into whole power n minus 1. Then p into e power 0. Here e power 0 value is equal to 1. Using this concept, and also q plus p also 1 here. So we will get mean value is np here. Now, before finding variance, I need to find this is nothing but mu1 dash. Mean is taken as mu1 dash. Now, mu2 dash. We need to find mu2 dash. Mu2 dash formula is mx double dash of t at t equal to 0. So, substituting t equal to 0 in equation 2 using the concept e power 0 equal to 1 and p plus q equal to 1. Using this concept, it will become which value is equal to n into p into np plus n into n minus 1 into p square. By simplification, we get np plus n into n minus 1 into p square, we get n into n square p square minus np square. Now our variance formula is denoted by mu2, that is nothing but mu2 dash minus mu1 dash square. So our mu2 dash value is np plus n square p square minus np square. Then mu1 dash value is np here. Using this value here, squaring we get n square p square. So minus n square p square plus n square p square get cancelled. After that, taking common n into p outside, it will become 1 minus p. So 1 minus p is nothing but q. So npq, it will become npq. Our mean value is np and variance value is npq. That's all. Thank you.